All right, so there's 3 questions on your review for week 11 that I want to go over with you, and just make sure that you have a good understanding on before your test tomorrow, because these are very, very important questions, not just for tomorrow, but for your EOC as well. All right, so this is asking you to compare the graphs, and it's non-calculator, which means you need to know a general idea of which each of these graphs looks like. So we're thinking about which function families they belong to. So this first graph, f of x, equals 2 to the x. If the x is in the exponent, that means that this equation is exponential. All right, so an exponential equation with 2 as the base means that this is growth, because that 2 is greater than 1. So I'm going to have this asymptote line and something that looks like growth. Notice, because there's no plus or minus out here at the end, that this asymptote line is at 0. And I would make a note for yourself that this is exponential. All right, the second one, g of x there, is x squared. Remember, anything with a squared exponent is going to be a parabola. So this is our quadratic, so I'm going to look at this parabola. Remember, if it doesn't have any plus or minuses, this right here is at 0, 0, for what that's worth. And then I'm just going to go ahead and make a note so that I remember that this is quadratic. This is why I have those things on the wall the whole time, is so you kind of get used to looking at the different families. All right, we've got x to the 1/2. Remember, another way to write fractional exponents is as roots. So this is to the second root, which is the square root of x. Now remember, square root of x is the inverse of quadratic. So normally quadratic, I'm going to go back for a second, is 1,357 over 1. This is square root, so that means this switches to 1 over 1,357. So when you go to graph, you're starting at 0, 0, and it looks like this. It's a parabola that's been kind of turned sideways and cut in half. All right, this is called the square root function. And then the last one, y equals 1/2 x. Hopefully you realize that last one is just pretty simple. That is a linear function, because there's no exponent, there's nothing happening in that equation other than the 1/2, which is a slope. So that's just rise 1, run 2. So I've got this graph that looks like this, crosses at 0, 0 there in the middle, up 1 over 2. All right, so now you're just doing domain and range for all of those. Hopefully you know domain and range and in behavior. Remember, and I'm just going to point this out, I'm going to let you fill this part out on your own. Remember that in behavior, this is in behavior on the right, because x is going to positive infinity, so you're looking on the right-hand side of all of these. Negative infinity is going to the left. All right, so the only one that I am going to point out to you and give you the answer for is the in behavior on this square root side on the left, because it dead ends. So on that case, because it dead ends, if it had an asymptote, you'd still put an answer, but when it dead ends, we're just going to say none. It's not going anywhere, so there's nothing to put there. All the others are going to have either a value or a positive or negative infinity. All right, and here's 3 and 4, which are on the next page. For both of these questions, you can go ahead and cross out B. We're not going to do that part, at least not without a calculator. You might do that part with a calculator, but we're not going to do that without one. So I'm really just going to focus on 3, and then you should be better about doing 4, or feel better about doing 4. All right, so question 3 here. I noticed this originally when I look at it, 3 to the x, this is exponential, which means when I first think about this equation, it's going to be what I just did. This is growth. All right. So if I go to name domain and range, domain is all real numbers. This says using set notation, so you can just say all real numbers. Range are the y values, and there's no plus or minus, so this is starting at 0. So for set notation, you do the brackets. You say the variable that you're talking about. So for range, I'm talking about y. And then we're going to do an inequality. So this is y is greater than 0. So that's what set notation looks like if you've forgotten. Now C says to write the inverse function. So we've been learning about this all week. The inverse of exponents are logs. Remember, that's like on those buttons on your calculator. Above the log button is the exponent. So if we do the inverse function, this is, and I should write it as a function, y equals, or you can write f inverse equals if you want to, log The base is 3, because notice the base on this other problem was 3, and x is the variable. So pretty simple. You're just changing it from exponent to log. We're going to state the inverses, domain, and range. And even if you don't know what this graph looks like, which I can show you and we can talk about that, but even if you don't know, domain and range inverse switch x and y. So then the inverse for domain and range are going to switch. So in this case, the domain of the inverse is the range that I had of the original function. The only difference is that because I'm talking about domain, I need to change my variables to be x's. All right. Then the range would be the domain that I had from the earlier function, right? And the domain on the previous function was all real numbers, so the range on this function is going to be all real numbers. All right, 4 is very similar. My suggestion on 4 is to actually do part C and D first, and then go back to do part A. All right, so that's all you need for those two parts of this review.